I'm going to be talking about limiting reactants, which is the reactant that runs out first and limits the amount of products that can form. The question is, a reaction 4.5 atmospheres of 50 grams of H2 at a temperature of 250 occurs with 100 grams of oxygen in a 10.0 liter container. After the reaction is complete and the temperature has returned to 250, what is the pressure of H2O in the container? This is the balanced equation that we will be using to find our limiting reactant. We will be using the formula PV equals nRT. To start out our problem, we are going to start with 100 grams of oxygen, and we know that because that's what we are given in our question. Then you're always going to start by putting what you were given over 1. Then to cancel out your grams of oxygen, you're going to put 15.9 because we are given that in our periodic table. Then on the top, you're going to put 1 mole of oxygen and then 2 moles of oxygen to cancel it out. And we find the 2 moles of oxygen and the 2 moles of hydrogen in our balanced equation. And then you're going to put 1 mole of hydrogen 2 on the bottom to cancel out the moles. Then 2 grams of hydrogen 2, and we are also given that in our periodic table. And after you multiply the top row and the bottom row, then you can divide them both together and you will end up with 12.5. To continue to finding our limiting reactant, we are going to find the grams of oxygen. So first, we will take 50 grams of H2, which we are given in our question, put it over 1, because you always do that with your given information. Then on the bottom, to cancel out grams of H2, we're going to put 2, and then we also found that in our periodic table. On the top, you put 1 mole H2. On the bottom, 2 mole H2 to cancel that out. And we found the 2 mole H2 and the 2 mole O in our balanced equation. Then you're going to put 1 mole of oxygen on the bottom to cancel out the moles, and 15.9 grams of oxygen on the top. And then you will multiply the whole top row, multiply the whole bottom row, divide them together, and you will end up with 397.5. After solving for these both, the first thing we do is see which number is smaller, 12.5 or 397.5. We can tell that 12.5 is a smaller number than 397.5. And we know that 100 grams of oxygen is our limiting reactant. We may have found our limiting reactant. We do not have all of our information to fit in the equation PV equals nRT. As you can see, our question has asked us to look for the pressure of H2O in the container. And here we don't have moles, and that's what we need to find. So now that we found our limiting reactant, we can plug it back in to find our moles of H2O. Okay, so we take our limiting reactant, which is 100 grams of oxygen, put it over 1, 15.9 grams of oxygen, which we already knew, to cancel that out, 1 mole of oxygen, put 2 moles of oxygen on the bottom, that we found in our balanced equation, cancel those out, and whenever there's a mole on the bottom, you will most likely always put a mole on the top. And then we have 2 moles of H2O, which we found in our balanced equation. Multiply the top out, multiply the bottom out, divide, then you have 6.28. Let's take this and plug it back into our equation. So now we have this and we will solve. You will end up with 128.8. And now we will solve for P. So then we divide both sides by 10, and then you end up with 12.88. We found our pressure, we can go back into the question, and we can look and see if we found our answer. So the whole question was asking what the pressure of H2O was in the container. So we found our limiting reactant. Then we used our limiting reactant to find our moles of H2O to plug back in to our equation. Then we solved out our equation and found P, which is pressure, and it was 12.88. I use limiting reactants to solve a problem. Thank you.